Welcome to the very first video of Tom Engineering. In today's video, we're going to be making our very own miniature wind tunnel. So, I'm an engineering student, and I've spent a decent amount of time learning about aerodynamics, including airflow, pressure gradients, laminar versus turbulent flow, and all that stuff. But as everyone knows, there's a difference between theory and actually seeing what's happening. One night, while doom scrolling, I came across some videos of people making their own homemade wind tunnels, and I thought that it would be pretty cool to have one of my own. That's when I realized that this is something that I could just build, and not only would it be awesome to have, but it would help me visualize all those aerodynamic concepts. The first thing I realized while starting the design process was that the test chamber, the part where you actually observe the airflow, needed to be transparent. Clear plastic was one option, but I didn't have any lying around that wasn't rounded or hard to see through. I decided to check the thrift store, and although it wasn't exactly what I was looking for, I found two matching glass panes, which I thought would make a nice sized observation window. From that point, the rest of the design built itself around those two pieces, a mist maker, and a variable speed computer fan. Now, let's get into it. All of the components that I used, I designed here on SolidWorks. This is the full assembly, which is made up of 5 parts. First, we have the main body, the core structure that everything attaches to. It's designed around the dimensions of the glass panes and the 120mm variable fan. I also added small hexagon cutouts on the bottom so that different objects could be mounted inside. Second, we have the observation window, which is a thin 3-sided cover with 2 rectangular cutouts where the glass gets glued in. I also added a section for an LED light strip so you could see everything inside. Although I was proud of the design, it's the part that actually gave me the most issues down the road. The fan mount was the third piece, and like its name says, it's just a bracket that holds the fan. This was also my first attempt at a press fit design meant to slot in without any fasteners. The fourth and fifth pieces make up the intake section, a converging duct that steps down from a larger inlet to a smaller outlet paired with a printed honeycomb mesh block. Together, these are meant to condition the airflow into something more laminar, which is more useful for visualization. All of this was printed on my new Bamboo Lab P1S with standard PLA filament. It was my first time using it for a project like this, and honestly the print quality and speed were a huge step up from what I was used to. The assembly process was straightforward in theory since every joint was designed as a press fit. The idea was that the tolerances in the print would be tight enough to hold everything together without the need of screws or any adhesive. Now let's take a look at how everything turned out. As you can see, 4 of the 5 prints turned out exactly how I designed them, but unfortunately my press fit design had some flaws. Turns out that the tolerances I made while designing the brackets weren't tight enough, and both the duct and fan mount weren't staying in place. Instead of adjusting the model and reprinting the pieces, which would have been pretty easy, I just decided to wrap everything up with electrical tape. That way I wouldn't have to waste any plastic, and honestly, I didn't really feel like waiting another 5 hours for a print to finish. Once I finished putting that all together, the fan was pressed onto the mount, and the mesh block slid perfectly into the intake duct. This left the final and most problematic part of the build, which was the cover. I got a bit impatient while slicing the print files, and tried to print the mesh block and the cover at the same time. Given how thin this part was, I probably should have just taken my time and printed it separately, especially since even by the looks of it, you can tell it would probably fail. Unsurprisingly, near the end of the print, the cover started warping, and by the time it came off the bed, it had visible imperfections. The glass panes weren't going to sit flush in a warped panel, so I had to deal with that before I could assemble anything else. Just like before, I was determined not to waste any plastic on a reprint, so I used a lighter to heat and reshape the plastic, then pressed it flat and held it while it cooled. PLA is actually pretty cooperative with this, and it'll hold the new shape. Once it was flat, I glued the glass panes in and they sat in pretty well. This isn't really a method I'd put in a design guide, but sometimes you just gotta get it done. And with that, we finally have our completed product. All that's left to do now is see if it works. Here's a close-up of what's happening. The fan pulls air through the intake, and the mesh block breaks up the larger eddies, then the converging duct accelerates the flow towards the test section. Here you can see the mist threading through. As you can see, everything works. The flow looks reasonably laminar at mid-fan speeds, and you can put a small object in the test section and see streamlines deflect around it. I got this car from the dollar store, and it was actually the perfect size for my wind tunnel. Let's see how it performs. Now let's see how it performs in the wind tunnel. The only negative is that the mist from the output fogger is pretty low. A better fog machine or a smaller body would have made this drastically more visible. Overall, I'm pretty happy with this as a version 1. The design is solid, and the Bamboo P1S handled the prints pretty well. If I were to do a second iteration later on, I already know what I would fix. This includes adjusting my tolerances, improving the mist production, and not rushing my print jobs. With that said, that wraps up the first video of Tom Engineering. If you want to see more of the SolidWorks files, have questions, or even improvement ideas, feel free to leave a comment below. Also, let me know if you want to learn how I built this custom tripod to film this video. Thanks for watching, and I'll see you in the next one.